Today's lesson is on graphs of logarithms. By the end of the lesson, you should be able to graph a logarithm function and find the domain and range. The vast majority of logarithms that are used in the real world have bases greater than 1. So exercise 1, consider the logarithmic function y equals log base 3 of x and its inverse y equals 3 to the x. Construct the table of the values for y equals 3 to the x, and then use it to construct the table of values for the function y equals log base 3 of x. Remember, input becomes output and output becomes input. It doesn't matter which way you're going. We are starting with the exponential and then going to the log. You could start with the log and then go to the exponential. So grab your calculator and do your values in the table. So this is what you should have gotten. Your input became the output in the log. Your output of the exponential became the input of the log. Now, when we graphed them, I drew in the pink line, which meant it was symmetrical because they are inverses of each other. Symmetrical to the line y equals x, or a reflection in the line y equals x. The other thing we need to talk about is the asymptote line again. The asymptote of the exponential was the x-axis. Or y equals 0. That was for the exponential. So now for the log graph, it's the inverse of it. So it's the y-axis, or x equals 0. So make sure you understand that the asymptote lines are very important. So the exponential graph is in quadrants 1 and 2. The log graph is in 1 and 4. So make sure you know your quadrants. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Okay? So that should be something from the past. So make sure you know your quadrants. So we already graphed them and labeled them. Now we need to state our domain and our range. So it keeps coming back. Every shape we do, domain and range is going to come back. So again, if I look at my graph, I notice that my domain of my exponential is always all real numbers. So negative infinity to positive infinity. My range is greater than 0. It's in quadrants 1 and 2. It's above the x-axis. So now my log graph, those become the inverses of each other. X becomes y and y becomes x. So now my domain becomes my range. So my range is negative infinity to infinity. And my domain becomes not y is greater than 0, but x is greater than 0. And you can see those things in the graph. So your domain is only, your x values are only on this side, only positive. So x is greater than 0. In your range, well, this is going to keep going up. So positive infinity, and it's going to keep riding that y-axis all the way down to negative infinity. So go ahead, pause the video, graph number 2, and state the domain and range. Hint, it doesn't change. So one of the things you need to know is when the base is 10, they're not going to write a 10 in the problem. So when you go to graph it, you do not have to put a 10 in for the base or the subscript. You can just put log x in, and as long as x is in parentheses, the calculator knows what to do. So on your paper where it says log base 10 of x, that is not very common, okay? They're just going to write log x. Notice the calculator knows there's a 10 in there. So we have to graph this, so get your table. Notice your values. Well, below 0 is undefined and errored. Greater than 0, they're very small, till you hit 10, 1. So let's get that on your paper. So your graph should look something like this. Your domain is x is greater than 0 because they're all on the right side of the x-axis. And your range keeps going up, keeps coming down. So all real numbers from negative infinity to positive infinity. Remember, you could also write, if you wanted to, the capital R. Go ahead and pause the video and try exercise 3. It is multiple choice. So you should have gotten an answer of number 3. Make sure that when you plug these in the calculator, you're looking at the table for these values in your table. So make sure that your table had the value 1, 1, 5, 2, negative 1, 0, negative 2, negative 1, and we can't really see the next one because it's in between. So you want to make sure that those are in there, okay? Again, remember that this negative 1 on the end means you went down 1, okay? All right, so now the fact that finding the logarithm of a non-positive number, negative or 0, is not possible in the real number system allows us to find the domains of a variety of functions. So go ahead and pause the video and make sure you highlight that and you know what that means. So remember, your base and your number cannot be negative or 0. So it asks us in number 4 to determine the domain of the function of y equals log base 2 of 3x minus 4. So just like above, let's use our example above. We notice that our asymptote is right here at x equals negative 3. Notice, what does that have to do with the equation? Well, it makes this 0. All of the values are greater than negative 3, all the x values. So this graph never touches that asymptote. So it's not going to actually equal 3. It's going to be greater than that, okay? So determine the domain. So we know that this piece in the parenthesis has to be not negative and not 0. It has to be positive greater than 0. So we're going to take 3x minus 4. It has to be positive greater than 0. So we're going to make it greater than 0 and solve. So add 4 and divide by 3. So x is greater than 4/3. It asks us to put it in set builder notation. So x such that x is greater than 4/3 in our set builder notation. Why is that? Because remember, in Ben, this is the number. Log base 2 cannot ever be a negative number. So 2 to some power, I can never come up with a negative answer. And 2 to some power is never going to equal 0. It always has to be greater than 0. Okay? Always, this n value piece has to be greater than 0. And that is key to what we do. All right? And the asymptote line is the line that if we were going to do it graphically, we would see that's where the asymptote line is. Our asymptote line for this one is at 4/3. It'd be hard to see because that's not a whole number, but we would see it's a little bit more than 1. So let's look at our last example. All logarithms with base larger than 1 are always increasing. The increasing nature can be seen by calculating their average rate of change. And that's what we've done all year so far. We've talked about the average rate of change. I like my ruler, and if I went from arrow to arrow, I would see that that is an increasing or a positive average rate of change. If I took those 2 points where the arrows are and made a line, I would see that's a positive slope. All right? So set up and evaluate an expression for the average rate of change of f of x over the interval from 1 to 10. So we're using log x. So grab your calculator and let's get some values. So we see in our table log of x, or log base 10 of x, same thing. So from 1 to 10. So our value at 1 is 0, and our value at 10 is 1. So our average rate of change is the change in y over the change in x. So let us change in y, 0 minus 1, change in x, 1 minus 10. So we have negative 1 over negative 9, or 1/9. Now they ask us to find the average rate of change from 1 to 100. So we already know 1 is 0. So if you go back to your table, holy cow, 100 is going to take us a while. So let's do menu, table, number 5, edit table settings. We're going to start at 0 and let's count by tens. We'll get there faster. So our 100 value is 2, which I should have known, because 10 to what power is 100? 2. So now we have our change in y over our change in x. So we have 0 minus 2 over 1 minus 100. So we have negative 2 over negative 99, which is 2 over 99, both positive. That's why they're increasing. What do these two answers tell you about the changing slope of this function? Well, since they're not the same, since it's not constant, it's not linear. We also know that it is getting smaller. So as x gets larger, the average rate of change gets smaller. And the slope of the line is getting smaller and smaller and smaller. It's flattening out to that asymptote line. If you have any questions, make sure you ask in class. Good luck!